This is TMUA question of the day, day 22. Hints with stopmaths.com and Tobin Payne. So our A-level plus question, it's sort of like simultaneous equations, except they haven't asked you to find x or y. They've asked you to find this interesting expression of x squared y plus xy squared. So my first hint would be, is there anything you could do with that expression? Maybe write it in a slightly different way. That might be a little bit more helpful. My second hint would be, don't leave this as it is. Anything with fractions in should be tidied up, simplified, so it's a bit more pleasant. Hopefully with those two hints, you'll be able to then get there. And remember, it's not the case that you need each of x and y. You just need x squared y and y squared x. And note that there's no limitations on these numbers. So it's, they can be any real number, positive, negative, etc., integer, non-integer. Now, our second question today is one that Tobin has rated as 10 out of 10 difficulty, and I know exactly why he's done that. He's put it in the functions topic because of this factorial, but there's a lot going on here, really. You could put this in the logic area because of the element of the counting. You're looking at how many different possibilities there are for a number. So, really is a tough question. But the first thing I would say here is get your head around what this number looks like. So we know all of its digits are different. So that means just on that constraint straight away, it can't have more than 10 digits. But actually, we have a further constraint that the sum must be 36. So how would we end up with a digital sum of 36? Well, a hint, think about what the sum would be if you used all of the digits from 0 to 9. And then think, well, what can we possibly remove? And then start to think of how many ways can you organize the digits that you've got. And once you've got that, you should start to be able to think about counting the number of options. Now, clearly, whatever the number of options is, 7 factorial is a factor of that. So the number of options, you're looking to factorize out 7 factorial and then see what n is. It's a tough question, so good luck, and hopefully that is a helpful hint. This question's an interesting one, and I've seen a lot of students who really struggle to kind of understand where the quarter circles are. My typical hint for any question like this is to try and draw centers of circles and radii at interesting points on the circumference. The challenge here is thinking about where the centers of those quarter circles are. And the quarter circle, of course, being this. And you've also got that these quarter circles have this common tangent. So try and get a bit more information with the shape. Try and think what those quarter circles look like. Try and think what the shape can look like once you've drawn those in. Lastly, our logic question. So having a remainder of 1 when divided by 3 is just almost a sort of primary level way of saying 1 more than a multiple of 3. So start to think of what kind of numbers are 1 more than a multiple of 3, and also 2 more than a multiple of 4. Note that if you have a number x, and we can use, by the way, modular arithmetic. Now, it's not explicitly on the spec for TMUA, but it's really nice sometimes to just be able to say something like x is congruent to 1 mod 3. So if you are interested in doing a bit of further reading, I would look up modular arithmetic. If anyone's doing edXL further maths and you're doing one of the optional pure modules, it is on that. So if x is has a remainder of 1 when divided by 3. So if x is 1 more than a multiple of 3, then x plus 3 is also 1 more than a multiple of 3. So hopefully that's enough to help you spot a pattern and then figure out how to count those. Thanks very much for watching. Any feedback, always appreciated.